So this question is taken from the IGCSE paper. It's the question number 5 and the extended paper 4. So quite a few bits to this question here. So you have 5A, 1, 2, and then we have 5B, which also has 2 questions. We need to find the volume of these, the container and the liquid in the container. So then we can start with the first bit. So that's asking about so you have this ABCDF is a regular octagon with sides of length 6 cm. The diagram shows part of the octagon. O is the center of the octagon and M is the midpoint of AB. So we need to show, not find, we need to show that angle OAM is 67.5 degrees. Now that is obvious, but we still have to work it out. So we work out using the internal angles of a regular octagon. So we calculate that. So internal angle of a regular octagon, that would be equal to 8 minus n minus 2. So 8 minus 2 over 8 times 180 degrees, and that is 6 over 8 times 180 degrees. So that's 2 times 3, 6, 2 times 4, 4 times 45, we get 135 degrees. So now OA is equal to OB, and internal angle, it was point H, I said point C. OA bisects the internal angle HAB or HAM, whichever we write. Then therefore angle OAM is equal to 135 divided by 2, that is equal to 67.5 degrees. So that's the first bit. The next bit is we need to calculate the area of the octagon. So the area of the octagon, if you were to draw an octagon again, and there's a center, there would be 8 of these triangles, congruent isosceles triangles. They don't look congruent in my drawing, but they are. So 1, 2, 3, 4, 5, 6, 7, 8. So then if I can find the area of triangle OAB, then I can multiply it with 8. So area of the octagon will be 8 times area of triangle OAB. So area of triangle OAB, half times base times height. We know what the base is. Side length is 6, so this will be 3 and 3. So I can write AM is equal to MB is equal to 3 centimeters. And I also know the angle, internal angle, half of that, 67.5. So I can say that OM I need to find. So tan 67.5 degrees is equal to OM over 3. So therefore OM would be 3 multiplied by plus 3 multiplied by tan 67.5. And so that's 7.24. So I get 7.24. OM is 7.24. So if OM is 7.24, therefore area of OAB, triangle OAB, sorry, would be half times base times height, half times 6 times 7.24. So therefore area of the octagon would be 8 times half times 6 times 7.24. So that is, I can cancel that out. So that's 24 times 7.24. That's 173.76. So I can write it as 173.76, which can be written as 173.8 centimeters square. So that is the area of the octagon. Now find the area of the circle that passes through the vertices of the octagon. So the area of the circle, it's, how do I do that? So all I have to do is, if I draw a circle around it, what you realize is this OA would be the radius. So these are all the radius of the circle, isn't it? So I can say, referring to the figure they have provided, that OA would be the radius of the circle OB. So I just need to find what OA or OB is, and that I could do, and I could get it. So OA OB is radius of the circle, and I can find OB by saying that, of course I could use Pythagoras, or I could say that cos 67.5 degrees is 3 over AB, 3 over OB, sorry. You can say cos of 67.5 degrees equal, that would equal 3 over OB. So that's 3 over OB. So therefore OB would be 3 divided by cos 67.5. So 3 divided by is 7.83, and so on. So if I say 7.8 centimeters, we are in centimeters, that 7.8 is OB. Hence the area of the circle, would be pi times r square. So 7.8 square, that's what it is. So 7.8 square, 3.142, 8 square, that's 191. Maybe I've simplified it too much. So I said 7.84 square, 3.142. Yeah, that's better. So I should write 7.8, it should be rather 7.84. It's oversimplified. So over area of the circle would be pi times 7.84 square. So then we get 193.12. So I can say 193.12. So I can write it as 193, approximately 193 centimeters square, which is the correct answer. So then the next bit, is there anything else? No. The next bit is we need to find. So the diagram shows a horizontal container for water with a uniform cross section. The cross section is a semicircle. Radius of the semicircle is this, and the length of the container is this. So we need to find the area of the cross section. Volume. Volume would be area of the cross section times length. So if I say volume equals area of cross section times length, then area of cross section times length. Yeah, so area of cross section would be, we've been given the radius 0.45, so it would be, that would be equal to pi times 0.45 square over 2 multiplied by the length, that is 4. So that will give me, multiplied by 0.45 square times 2. That's 1.27. So I get 27 and so on. This ignoring the other digits. So I get the answer as 1.27 meter cube. And then we have got this bit. So here we need to do some work here. So the greatest depth of the water in the container is 0.3 meters. The diagram shows the cross section. Calculate the number of liters of water in the container. Give your answer correct to the nearest integer. So if we are going to mark this as a center, it is a center of the circle. And then, if I join these sorry. So then this is the radius, isn't it? So this is the radius we've been provided, 0.45. So this is 0.45, 0.45. So our challenge is to find this area. Now I think this area is equal to the cross-section area. The shaded area is, if I say shaded area is equal to area of sector if I name it OA and this point as XB, OAXB minus area of triangle OAB. So I need to name this point something against BP. So then the area of what other things we know? See, OX is also equal to 0.45, 0.45, and therefore OP is equal to, no, OP is perpendicular to AB. OP is equal to 0.45 minus 0.3, that is equal to 5, 0.15. So OP is 0.15. Then I can find OP. Uh, 0.15. So then that's a bit bigger, easier to see. So then 0.15. So now I need to find the area of, no, before that I need to find the, I must find the I must find the sorry, I need to find PB, so this bit. So that would be using Pythagoras theorem, PB. So PB is equal to AP is equal to the square root of 0.45 square minus 0.15 square. And that's 0.18, and I need to do the square root of that, and that will give me 0.42. So I get that is 0.42 centimeters. Oh, sorry, it's all in meters. Right. So this is in meter. Okay. So then 0.42 meters. Now, so I know the area of the triangle OAB. Area of triangle OAB is equal to half times base, so that is 0.42 plus 0.42, so that is 0.84 times the height 0.15, so that is 0.84, sorry, multiplied by 0.15 and divided by 2, that is 0.063. So that is equal to 63 meters square. So that's, I hope I did it right. Yes, so that is the area of the triangle. Now to find the area of the sector, we need to do one more thing, that is we need to know the angle AOB. So what is this angle AOB? So it is, if I say that this is alpha and this is alpha, so let angle BOP is equal to angle AOP is equal to alpha. So we need to work out what this alpha is. So then we can use, I would use the cos alpha. Those figures are given to us is 0.15 over 0.45. So therefore alpha would be cos inverse of 0.15 over 0.45. Now to work that out, so cos inverse of 0.15 divided by 0.45, and that is equal to 70.5. So that is 70.5 degrees. So then we get 2 alpha is equal to 141 degrees. So now we know that area of the sector, we know the formula. So OAXP, so I will write area of the sector OAXB is equal to pi r square. So pi and r the radius, and that remains 0.45 square times 141 over 360 degrees. So that is equal to 3.142 multiplied by 0.45 square multiplied by 141, and that's divided by 360, and that's 0.249. So I get that is equal to 0.249. That's the area of the sector. So area of the shaded part, so hence area of the shaded part equals the area of the entire sector, so 0.249 minus area of the triangle, that is 0.063. And that's 0.186. Meters square. Now hence the volume of the water, number of liters of water, so the volume of the water would be 0.186 multiplied by the length. The length we have been given, that's 4 meters, isn't it? The length is 4 meters. So what we get is multiplied by 4. So when I do that, I would get 0.744. but that is in meter square. We need to find the answer in liters. So we know that 1 liter is a, well, 1 meter square. Um, to convert it, I have to multiply it by 1000. Okay, so 0.744 multiplied by 1000, that would give me the answer in liters. That's because this meter square, I can convert it into sorry, not square, that would be cube. How silly of me. That would be cube. So that to convert, I could convert it 0.744 times 100 times 100 times 100. That would be in centimeter cube, and convert it back to liters. I divided by 1000. So that's the working, but what it would come to is 0.744 multiplied by 1000. So then that the answer we would get is 744 liters. And that's the correct answer. So that's done. So done all the parts smaller. So then the parts are done. So, and that's the first bit. So that's the 5A. And then if I go here, then I have it all completed. So that's all done, all correct.